Okay, so question 7. Which series of transformations correctly maps parallelogram A, B, C, D to parallelogram A prime, B prime, C prime, D prime? So how I'm just going to first look at the options and then use some just talking through and seeing what I know about it. So rotation 90 degrees clockwise about the origin, followed by a translation 3 units down. A translation 3 units down, followed by a rotation 90 degrees clockwise about the origin, a reflection in the x-axis followed by a reflection in the y-axis, a reflection in the x-axis followed by a rotation 90 degrees clockwise about the origin. So I'm thinking to myself, okay, which one of these am I the strongest at doing, because that's the quickest one to check. So I'm the strongest at reflections, and so I'm going to go to the one that has reflections. So a reflection in the x-axis would be along this line. So since D and C are on this line, they aren't going to move. There's not a distance to be preserved because the distance is 0. They're on that line. So we have to preserve a 0 distance. So with that being said, let's just reflect our point A. So it is 2 units above the x-axis, so now it'll be 2 units below the x-axis. B is also 2 units above the x-axis, so now it'll be 2 units below the x-axis. So there's our reflection over the x-axis. So now let's see if it's followed by a reflection in the y-axis. So I'm thinking to myself, okay, before I rotate it, I'm just imagining this being picked up. So I'll just rotate one of them and see. So since this is C, and it is now being reflected over the y-axis, which is here, it is 2 units to the left of our y-axis, so if it was reflected, it'd be 2 units to the right, which it doesn't match up because C prime's right there. So this one's off the table. So that's how I would eliminate that one first. It was my strength to reflect, and it's not it. So now I would go to the next one that has a reflection in the y-axis, followed by a rotation 90 degrees clockwise about the origin. So I'm thinking to myself, okay, so if A was reflected in the y-axis, here's our y-axis again. So I'm counting 1, 2, 3, 4 units to the left. It'll now be 4 units to the right. 1, 2, 3, 4. So that's where point A would be. And point B is 1 unit to the left, so it would be 1 unit to the right. C is 2 units to the left, so it would be 2 units to the right. And D is 5 units to the left, so now it'll be 5 units to the right. So that's the reflection in the y-axis, followed by a rotation 90 degrees clockwise about the origin. So how do I do my rotations? So I use the L. So I count up 2 over 4. So now 90 degrees clockwise, that would bring this line flat here. So it'd be over 2, down 4. And A does not land right there, so this one is off the table as well. So now it has to be a rotation 90 degrees clockwise about the origin, followed by a translation 3 units down. So, or a translation 3 units down, followed by a rotation 90 degrees clockwise about the origin. So these two just have the order switched. Since I do notice that A prime is lower, I would first actually try the translation 3 units down. So if I translated this 3 units down, A prime would end up being right here. Not A prime. The first translation would end up being sliding it down 3 units. 1, 2, 3. So that's where A would be after the translation. B would be 3 units down, 1, 2, 3. C would be 3 units down, so 1, 2, 3. And D would also be 3 units down, so from here it's 1, 2, 3. So this is where it would be after the translation down 3 units followed by a rotation 90 degrees. So to rotate 90 degrees, I'm going to use the L again. So from our starting point, which is the origin, it goes back 4, left 1. So 90 degrees clockwise would rotate this up. So this would actually be up 4, left 1. And that is not lining up with where A prime is. And so let's check this one, a rotation 90 degrees clockwise about the origin followed by a translation 3 units down. So if we were to rotate A, it is up 2 units, left 4 units. So if I were to rotate that 90 degrees, it would be over 2 units. And since I went up and to the left, I'm going to go now flat, and I'm still going to go left though. So 1, 2, 3, 4. So that is where A prime would be. And I'm actually going to just check, since I know that rotations are rigid transformations, which means that this whole shape, the size of the length of the side lengths and the angles would be the same. So I'm going to just check the A prime after followed by a translation 3 units down. 1, 2, 3. It matches up. So since it is a rigid transformation, I wouldn't have to check anymore. And that is our option.